Solve m plus 7 over m squared plus 2m minus 8 minus 7 over m squared minus 4m plus 4 equals m minus 7 over m squared plus 2m minus 8. So the first thing that I do is, of course, I'm changing subtraction to adding the opposite. I also put my binomials in parentheses and then factor the denominators. So here for the first denominator, I'm looking for the factors of a negative 8 that add to a positive 4, and that's how I got the plus 4 and minus 2. So that factors to m plus 4, m minus 2. For my second denominator, since again my leading coefficient is 1, I'm looking at the factors of a positive 4 that add to a negative 4, which would be negative 2 and negative 2. So that denominator factors to m minus 2 times m minus 2. And the third denominator is the same as the first, so that factors to m plus 4 times m minus 2. So the next thing that I do is I want to go ahead and clear my fractions. To do that, I multiply each term's numerator times the least common multiple, or the least common denominator, which in this case is m plus 4, m minus 2, and m minus 2. So I need to multiply each numerator by that common denominator. This will clear the fractions. So for the first term, the m plus 4 and the m plus 4 reduce. One factor of m minus 2 reduces, and so that leaves me an m plus 7 times the remaining factor of m minus 2. For the second term, m minus 2 reduces, and another m minus 2 reduces, leaving me with negative 7 times m plus 4. And for my last one, the m plus 4's reduce, one factor of m minus 2 reduces, and that leaves me an m minus 7 times an m minus 2. My next step is going to be to expand these. So I'm going to use the FOIL method, or the distributive property, to multiply m plus 7 times m minus 2, and then multiply negative 7 times the quantity m plus 4, and then again for the last, use the FOIL method or the distributive property to multiply the quantity m minus 7 times m minus 2. After distributing, I end up with m squared minus 2m plus 7m minus 14. And then when I distributed the negative 7 times m, I got negative 7m, and negative 7 times positive 4 gave me a negative 28. And then again, when I used the FOIL method or the distributive property, I ended up with m squared minus 2m minus 7m plus 14. Now I'm going to combine like terms. So on the left-hand side, I have my m squared. I'm going to combine now the m. So I have negative 2m plus 7m, which is 5m. And then 5m minus 7m is negative 2m. And I have a negative 14 and a negative 28, which will give me a negative 42. Now I'm going to combine the terms on the right-hand side. So I have an m squared, a negative 9m, and a positive 14. So now I need to solve. So since I have a quadratic, that means something raised to the second power, I'm going to try to get those on the same side and set it to 0. But you'll notice when I subtract m squared from the right-hand side and the left-hand side, I no longer have a squared term. So what I'm going to do now is solve for m by isolating m. So I'm going to isolate it by moving the m's to the left-hand side. So now I'm going to add 9m to both sides. So that'll give me a 7m minus 42 equaling 14. And then I'm going to add 42 to both sides. And that gives me 7m equals 56. And then I'm going to divide both sides by 7, so m would equal 8. You need to make sure that this doesn't make any of the denominators equal to 0. So since our original denominators were m plus 4, m minus 2, and m minus 2, m minus 2, and m plus 4, m minus 2, this solution, m minus 8, fits within our domain.